In this video, we are going to use Descartes' rule of signs to determine the possible number of positive, negative, or imaginary roots of a polynomial. So let's start with our polynomial, polynomial p of x. And let's see, we're going to say 9x to the third power minus 4x squared plus 10. And what I'm going to do is I'm going to actually make a little table. Okay, I'm going to say for positive roots, and we're going to make up possibilities of negative roots. So positives, negatives, and we'll do imaginary. I'm just going to put I am for imaginary. Okay? Now, what Descartes' rule of signs says, it says the number of positive real roots of p of x equals 0 is either equal to the number of sign changes between consecutive coefficients of p of x or is less than that by an even number. Now, that sounds weird. Here's what we do. We take the original polynomial. We don't fill in with zeros in any missing terms. Okay? And we're going to look for changes in signs. So this is going from positive to a negative. So yes, I had a sign change. I'm going from negative to a positive. Yes, I had a sign change. So that means I could have a possibility of 2 positive, okay, or less than that by an even number. Well, the lowest even number is 2, so 2 minus 2 is 0, so I could either have 2 positive real roots or 0 positive. Now, to determine the number of negatives, we have to replace all x's. We find p of negative x. So what does that do? Well, in place of every x, you plug in negative x. All it does is change the sign of the terms that have an odd degree. So that would make, if I plugged in negative x, I would have negative 9x cubed. But see, squared terms, it will not change the sign, because when you square a negative, you still get a positive. So it stays the same. Minus 4x squared, and constant values stay the same, plus 10. Now I look for sign changes. Well, I go from negative to negative. There's no sign change. From a negative to a positive, yes, we have a sign change. So that means we have exactly one sign change. Since my degree is 3, all right, all of these have to add up to 3. So if I have 2 positive, and I definitely will have 1 negative, that means I would have 0 imaginaries. I definitely have 1 negative because there was 1 sign change when we plugged in negative x. But if I had 0 positive and 1 negative, that's when I could have 2 imaginaries. So we know there is definitely 1 negative root, 1 negative real root, possibly 2 or 0 positive, and then possibly 0 or 2 imaginary. All right, enjoy finding them. Bye-bye.